So in this video then, I'm going to be talking about the Boltzmann distribution. Now, Boltzmann is something that appears at AS level and is never actually expanded on going into A2. So what you get at AS level is essentially everything on Boltzmann, and in the final exams, it's possible, it does happen, that they will ask you a question on the Boltzmann distribution. And it might actually be a 4 or 5 mark question. And if they ask you such a thing, it's a godsend because they are some of the easiest questions you will ever get to answer. However, students typically struggle with these because they don't revise Boltzmann. Okay, because either it's too easy or it's not something they thought would come up because it's a very basic concept. However, it comes up more often than you'd think, and it's really useful to be able to just quickly and easily get these questions correct. Okay, if you see a 5 marker on Boltzmann, you should be spending 2 or 3 minutes on it and moving on. Okay, and using your time on more complicated questions. This is a very, very straightforward idea, Boltzmann. Very easy to go wrong, however, so we're going to quickly go through the common pitfalls on one of the questions just to show you what I mean. So this is a cover-all question. This is a 5 marker on Boltzmann. This is an absolute dream of a question. So all this is nonsense at the top. It's just about making ammonia. The question is, explain using Boltzmann distributions why increasing temperature and using a catalyst both increase the reaction rate. So this is basically saying just draw everything you know about Boltzmann. They give you a nice space. So this is where my drawing skills come into play. Now, you're going to need two axes, obviously. Now, you will obviously use a pencil and a ruler for this. I am not using a pencil and a ruler, so this may not look great. However, we'll give it a go. Yeah, that's fairly straight. That's not bad. Okay, that's doable. I can live with that. Okay, and we'll go across. There we go. Perfect. Now, the important things about Boltzmann. There are marks for labeling the axes. So you will need to label energy on the x-axis. You don't need units, just energy will do. And on the right, number of molecules, number of particles, number of whatever, it doesn't matter. Okay. In fact, in terms of how I'm just going to, number of particles will do. I'm not particularly bothered. Okay, number of particles, it's just the amount. Now, to draw the Boltzmann curve then, this is the hard bit. Now, your Boltzmann curve has to start at 0, 0, okay, because particles can't have zero energy. That's not how it works. So start at 0, 0, you can't go wrong. You go up, okay, we keep going up, and then we curve and peak, and then drop down, and then level off, okay. It's an asymptote, so for those non-mathematicians, it basically means it never touches the x-axis. So this line at the end here never goes back down to 0. It's an asymptote. Okay, theoretically, a particle can have up to infinite energy. Okay, it's very, very unlikely, but this is simply, a distribution. We're not going to get that high. So make sure it starts at 0, 0 and does not touch the axis at high energy. Now, we'll do a couple of things here just to make it easier. We're going to explain how a catalyst increases the activation rate and temperature. First thing you want to do here, okay, I'm going to use some different colors for this because I think it makes it a bit easier to see. We're going to mark on here an arbitrary activation energy. Okay, doesn't matter where, this is a sketch. Okay, but we're going to mark on an arbitrary activation energy and just dash the line. Okay, I just put a solid line. There you go. There's my activation energy. So that means any particles above the activation energy, so all of these can react. Okay, nice and straightforward, yeah? Now, what we're going to do next is put on what happens when we add a catalyst. So I'm going to do catalyst first because it's a little bit easier. Okay, catalyst first. So for a catalyst, all that's happening is the activation energy is getting lower. So we draw on a second activation energy, EC, connect it up, and then shade in all this, okay, because all these particles now have the required energy. So then all you write underneath is, with catalyst, more particles or more molecules, whatever, have energy above activation. And that's it. Done. That's catalyst done. Nothing more is required here. Okay, so for catalyst, it is simply the idea that you have an activation energy and you have a catalyzed activation energy, which is lower, so a higher proportion of molecules will have the greater than required energy. That's it for catalysts. Now, in terms of exam technique here, you can draw everything on one Boltzmann graph. I would probably steer clear of doing that because it can get quite messy if you're not careful. So I've nice and neatly highlighted all of this. I'm going to rub all this out now. Okay, now in the real exam, I'll just draw two curves. I'll just draw two of them because it makes it nice and easy to see. Again, remember, it's not about ease of doing it for you. It's about how easy it is for the examiner to see what you're doing. Okay, now I have marked papers in the past for exam boards. Okay, and the best thing I like about some, the best thing I really want to see every time is a student that will lay out their answer in such a way that I barely have to look for the answer. It's there and it's obvious, really, really flipping obvious. Okay, so make sure you lay out your answer so that if you were to look at it, you can see quite clearly where everything is. If you need to draw two Boltzmanns, just draw two of them. Okay, the first one I've clearly shown what happens with the catalyst. And now I'm going to do one for temperature, and I'm going to have to draw a second Boltzmann curve because remember now, at higher temperature, the energy of the system is going to rise. So all the energy of the particles is going to go up a bit. So when you draw a second curve, you need to start at 0, 0, as before. Okay, and you need to draw a shallower curve that peaks to the right of the original and finishes at a higher value. Now, these are sketches, so they do not have to be accurate, well, not completely accurate. So realistically, the area underneath both curves should be the same because that represents the number of particles in total. However, it's a sketch, no one's going to do any integration here and find out. But a couple of points to note. For a higher temperature, the higher temperature curve must be lower than the original, and the peak of the curve must be further to the right. Okay, it must also finish at a higher number of particles. So now to prove what happens, if we draw on our activation energy, okay, this time the activation energy just stays there, and at a higher temperature, all of the shaded particles now have higher than the activation energy. So higher T, more particles have energy, have E greater than EA. There we go. That's it. That's all you need to do. And those two explanations and those two graphs will get you 5 marks. Again, there are pitfalls, okay, and the typical pitfalls are the drawings of these graphs. Okay, so it's paramount importance you don't be lazy here. Okay, you have to draw this the higher temperature lower and to the right. I would also label them as well, so maybe just label it high T, and also for the blue one, just label it as low T, just so the examiner is absolutely clear on what you're doing. As long as you've drawn it correctly and it looks something like this, it's fine. So you'll need two Boltzmann curves, one for temperature, and you'll need the other one for the catalyst. Again, there's nothing saying you can't do the catalyst on this one as well. It might just look a bit messy. If you're not great with handwriting or you're not good at laying things out, it's possible that you might overpopulate your curve, make it a bit hard to see things. I'm not saying don't do it. It's entirely your decision, but I would just draw two curves. It makes everything really obvious. And then obviously include your explanation as well. You don't have to put, by the way, the explanation, they give you all these lines to write the explanation on. You don't need to write anything on those lines to get all the marks. Okay, if all your explanations are on the diagram and you've written down, essentially, what I've done here, higher T, more particles, E greater than EA, that's enough. Okay, the answer lines can be left blank. Okay, you do not need to write anything on them. So I don't think you've got to do all this and then write an essay. It's not necessary. The diagram is where most of the marks are. Your explanations can be written on the diagram. next to the relevant sections, and you get full marks for that. Nice and easy. So there you go. That was a quick one on Boltzmann. I'm not going to do any more because, again, these are all the same. They're always the same. Variations on a theme. This is all they can ask you. This is almost the hardest question they could ask you, which is doing both at once. But in reality, this is hard to get. And if you do get these exam, make sure you understand and learn it properly, because it's such an easy 5 marks and you can't afford to throw these away.